You're on mute, Neil.
Been doing that so much today. It's so annoying. It's been obviously that long since I've done Zoom.
Welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to think about pedagogy, teaching and learning, professional development, anything of interest to time poor but enthusiasm rich primary teachers. This week, I'm joined by Neil Almond.
Hello there, Kieran. Good to see you.
Good to have you back, Neil. It's been a while.
Feels like it's been a while.
I mean, it's probably much less time than we think. This time's flown by. And today we're going to explore a tiny bit of variation theory and perhaps explore the relationship between variation theory and other sort of education theories. But first, Neil, what you reading for?
Hey, what you reading for?
To carry on, this is where listeners will be able to know when the last time that I was on, the handwriting theme that we're going on with. Still working on it. This is a paper from 2022 by Polido and Theriault, and it's called Manuscript and or Cursive, the contribution of research conducted since 2012 on handwriting instruction. Cut a long story short, in 2012, there was quite a big synthesis of handwriting research that sort of tries to focus on to answer the question of should we teach kids manuscript or should we go to cursive straight away. And again, they've kind of updated that synthesis based on the last sort of 10 years of handwriting research. I'm not going to go into saying what the research says about manuscript or print or cursive handwriting. I will let listeners get the opportunity to read that in a forthcoming chapter all about handwriting that will hopefully be out around April time when it's finally finished. What about you, Kieran? What are you reading for?
Nice. I mean, I've never seen someone prepare as much for a chapter in a book. You will be the world's foremost handwriting expert by the time this thing's comes out.
I think what I'm aiming for is that the pages of references that are used in my chapter are actually longer than some of the chapters in the entirety that other people have used. That's kind of my benchmark, which probably means that people quite rightly will just be turned off and think, gosh, this is far too much for such a seemingly simplistic aspect of education. But I'm hoping that, if a few people read it and they are interested and it kind of sparks a bit of a conversation, then I'm happy. It's the self-learning that's, that's the real benefit here.
I mean, I think it will be really useful because handwriting is one of those things. It's like reading for a long time, just sort of swiping around in the dark, hoping that whatever you're doing is impactful. So I'm excited, and I think a dangerous precedent set by trying to out reference the other authors in the in the thing. We'll see how that works out.
Yeah, that might have to be cut.
No chance. So I have been reading a paper by Angelica Kuhlberg, Camilla Bjorklund, and Ulla Runeson Kempe, who are, I don't know, they're big players, frequent names on Martonian variation theory papers. And they have a paper called See Number Relations When Solving a Three-Digit Subtraction Task. And that is, I think it was published in 2024. I assume most of the work was done in 2023 because otherwise they've had a very busy January. And basically, the variation theory of learning was used to analyze what number relations the students experienced and how they experienced them. And so using this variation theory, this lens to see essentially where pupils went wrong and how they solve problems. And so we're going to talk a bit about variation theory in our research ed talk that we're taking on to around the world at the minute. We often talk about how the next step is to see what people experiences like in classes and things like that there. And what's really important about this is that they're identifying what they think students need to discern in order to solve subtraction tasks. And that's where variation theory can become really useful because normally it's very much a case of this is what was discerned And now they're moving towards, well, this is what was needed to be discerned to solve these problems. And obviously, three-digit addition or three-digit subtraction, sorry, is right in the primary ballpark. So exciting paper. About 55 kids in the study, I think, and really, really interesting.
Sounds really interesting. I'm looking forward to at some point being able to read it, but no doubt the expertise that you bring is going to mean that we can definitely probably incorporate it. We've already done this talk once, didn't we, at Research Ed National, and we were pretty confident that we would update it periodically before we bring it out again, because yeah, we've found an interesting rabbit hole, haven't we, Kieran, looking at variation theory, a rabbit hole that I didn't really appreciate would lead us to where we are, but there we go.
Absolutely. I mean, I think we've got 4 weeks until Warrington, so we've got plenty of time to update. And I can count at least 6 papers since we gave that talk in September that we might need to consider. Certainly for my data section, I need to update it with that. So we're gonna focus on a little aspect of variation theory, a thread that appeared when we tried to read as many papers as possible in the variation theory lineage. I think it makes sense to start with a brief description. Lots has been said about variation theory, but when we're talking about it here, what do we mean? What is variation theory, Neil?
Well, I suppose kind of, not to give too many spoilers, it would depend who you ask. If we're going for, say, the Martonian, where certainly variation theory, the name variation theory certainly kind of stems from his research, all the way across, I believe, Sweden, is where he performed lots of his research. But variation is intended to really identify how people create or take, novel meanings and make them their own, effectively assign, meaning to phenomena. Crucially, though, through discerning the ways in which things differ in certain respects, but otherwise have a degree of sameness. So, in other words, the only way that we can actually learn something, let's say a color, for example, the only way that we know that there are a multitude of colors is because we can at points compare and contrast those different colors. So we know where red stops and where it begins, in contrast to something like orange, for example, which would evidently, slowly bleed into each other. So yeah, I think that's a short, pithy, sweet idea what variation is, how people take novel meanings and make them their own from, say, discerning the ways in which these phenomena, these concepts may differ or in some ways be similar to different concepts. Don't know if there's anything you want to add to that one, Kieran?
Yeah, I mean, the only thing I would add is, and this will test my memory, variation theory is based upon a very specific philosophical position. I think Martin, 1976, it was a paper about phenomenography.
Yep.
And it was distinct from phenomenology, which is the observance of phenomena. And in this paper, he outlined the philosophical position. And essentially, to boil it down, because I think I've mentioned this before in the podcast, and I couldn't remember if it was a full episode or it was just us talking about research and philosophical positions. But it's all about experiential descriptions and describing the experiences of the person who's observing the learners.
Yeah.
And perhaps even the learners to an extent as well. And so when we think about variation theory and we think about the research into variation theory, there are certain assumptions that are being made, and they are not assumptions of a positivistic nature. And so that's where really I think our conversation today becomes really interesting, because actually there are threads that, although not referenced, tie together some different philosophical positions, I think. Like you said, spoiler alert. In your opinion, is it possible to consider variation theory in isolation?
Bit of a loaded question, that. Well, I mean, prior to doing all the reading that we did, and I can't really remember why we decided to do variation theory. I hate to think that the reason was, oh, we thought it would be simple and straightforward. Um, it turned out not to be the case. I think I remember so the answer is no, to not beat around the bush. But the reason why I sort of now think the answer is no, I think it came about because we were looking at, I think it was for the podcast, the variation, not variation, cognitive load theory 20 years later or 20 years on from that sort of conception. And I just remember the reading a section on that about the variability effect. And I was looking at that and, in my head, I'm sure I asked the question, like, isn't this just really describing effectively what, variation theory is? And going back to the point that you just made, variation theory takes a very different philosophical standpoint to those more sort of uh, cognitive aspects of learning, such as cognitive load theory. And so, say to answer, and then from there on, we found things out, uh, even more. We know, for example, that Gu and Bianchi, so over in Hong Kong and China, he was doing lots of work around the same time as Martin in Sweden, and they've collaborated on a few papers as well as to how they came about and those differences. So I really don't think you once you see these connections between all these different areas and all these different understandings of learning theory, no, I don't think you can sort of see it in isolation. I think it then becomes impossible, right? I mean, literally, you could apply the the philosophical look at variation theory and what it is. Right? Once you discern these differences, similarities between them, right? It becomes ingrained. You can't unsee it all of a sudden. So, for me, definitely not. And there's just too many reading the literature from different aspects and different parts of philosophical arguments and theories of learning. There are just too many coincidences for me for it to be considered accidental.
We have variation theory. We have Bianchi, and
Yep.
essentially they are descriptions of the same idea. There are two more sort of crossover fields. What are those two fields?
Yeah, so as I mentioned, we've got cognitive load theory, particularly in relation to the variability effect. The variability effect occurs when we increase the increasing variability exposes learners to a greater range of related tasks designed to teach about a specific concept or procedure, and then this in turn yields increased test performance, allegedly. Here in the cognitive load aspect, we talk about, and I think it's Craig Barton talks about these ideas as well, this idea of concepts having a surface or kind of structural feature, and those determine the variability of particular concepts. So something like Craig Barton's same surface, different, is it depth? Is that the way SSDD problems would kind of, although he takes those ideas as from a sort of variation theory, they fit quite nicely into this idea of the variability effect within cognitive load theory. And then I think the biggest surprise, certainly for me, when coming across this, is the variation that's implied throughout Engelmann's direct instruction. So capital D, capital I. People may know that from the results of the wonderfully named Project Follow Through, which was not followed through because direct instruction came out as the most effective method of teaching primary aged pupils, and in terms of outcomes like academic well-being, etc., far exceeded anything else within that sort of that was involved in that study. So we've got kind of four areas, some related, some quite distinct from sort of that philosophical position of variation theory in the sort of the Swedish perspective. But quite interestingly, in terms of, it covers quite a few philosophical positions. Bianchi was very much a sort of trying to almost like codify good teaching, purely of mathematics. So like an early attempt, I think, of what teach like a champions become, and it sort of, focuses on highlighting essential features and clarifying the connotations of concepts, crucially by initially sort of excluding and then sort of including what they call like the inference of background and non-essential features, i.e., what can we take out that is non-critical to understanding this concept, and then what can we bring back in so that pupils can then discern the difference.
The really interesting thing, and I think we may have discussed this before, is that we use lit maps to trace from a central paper in both directions, papers that have cited it and papers that have been cited by it. And the really interesting thing was that even though you've spotted the relationship between these four different fields, the referencing doesn't show that in the slightest. It was only additional reading by you, Neil, that brought this to light and then led you, like you said, a rabbit hole in search of sort of correlation.
Yeah.
Do you think we'll ever get to the point where variation and, I don't know, direct instruction research and cognitive load theory research are sort of referencing each other if they're sharing? I mean, we will come to the similarities, but do you reckon is the gulf just too wide, or are we imagining that there's a gulf and perhaps actually it's just coincidence? What do you think?
Is the £20,000 question, isn't it? I would like to think, again, there are some similarities, there are some cross references, not anything as extensive as I would have liked. What's quite telling is the amount of self-referencing that Martin does. Martin, so from the sort of the Swedish idea of variation theory, really does enjoy referencing his own work a fair bit. And as kind of Kieran mentioned, he's not too concerned with sort of empirical data and sort of definitely not interested in sort of the more sort of cognitive elements. So those papers that have kind of cross-reference haven't been from these sort of main people, although we definitely do start to see a little bit of what I would call the disciples of Martin and the disciples of Gu. So I'm thinking particularly Pang and Guo, who should not be confused with Gu. I thought I found the paper at one point. It was clearly late at night. And as I say, just that one letter made all the difference. And then sort of that central pillar, that's what I thought, the heart that connected all these different bits of variation theory together, turned out not to be the true at all, which was obviously quite sad. So we do see a few connections. The main outlier is the capital D, capital I direct instruction. That certainly seems to be almost, excluded from this other literature, but we do see the likes of Guo, who, as I say, is almost a disciple of Bianchi and Martonian variation theory. He definitely seems to be a central pillar in sort of driving this research forward. So he goes back to the original variability effects paper by Pass from 1994. He references Martin as well from 2013. And he, interestingly, Rittall Johnson as well, who you gave us a little introduction to there. But I don't know if you can superimpose just static images on this, Kieran, but you'll be able to see if Kieran is able to, that direct instruction, capital D, capital I, certainly does sort of live in its own universe in comparison to those others.
Universe is quite apt because it does look like little collections, like little solar systems of planets all threaded together by these lines when you use the software. I mean, maybe we shouldn't say the company's name again until they start sponsoring us, or at least give us free access.
Absolutely. So
But,
Litmaps, if you listen to this,
yeah, let's tag them in. I want that 120 quid back.
Worth every penny.
I mean, self-preferencing is a big thing in education research. I mean, it's probably a big thing in research, and certainly when as we've been going through like our Under the Microscope series, where we've looked at different authors and their work, the longer you're in a field, the higher the chance that you're going to reference yourself. But I think it's fascinating, and particularly in light of the relationships and the just the different ways of describing very similar phenomena. And you know, I just want everybody to be friends. I want them all to say, "Yeah, this is all great." But variation theory in particular feels like a place, a space that is being, I don't know, constantly fought over. And I'm sure fought. It's probably just debate or discussion. But it feels like, even though it's been discussed for quite some time, the conversation still feels quite new, and so there's a lot of for grabs, so to speak. But yeah, I find it really interesting. You've already mentioned the variability effect. Where do you find overlap between variation and these other fields?
I'll go through sort of each part in turn, and kind of hopefully that will demonstrate to people how it all works. So when we're thinking about Martonian variation theory, so from Sweden, he basically sees that variation takes place in sort of four different ways. There's contrast, so that's where a learner kind of experiences variation of different values or features in an aspect of a phenomenon. So in other words, for you to truly understand what a triangle is, you have to contrast this idea of triangle to other shapes that definitely are not categorically a triangle. So a non-triangle, or a type of non-example, if you will. There's separation, and that's when a learner focuses on a particular aspect of a phenomenon. So again, going back to our sort of triangle idea, we may want to discern that the idea of a triangle having three sides and it's a closed shape. So we're actually going to vary other parts of a triangle, such as the size, the type of triangle, the height of it. All of those are going to be kind of kept invariant. So we're not going to change those, but we are going to vary the aspect of a closed shape, perhaps. So what I might do there is find subtle ways to make sure that the triangles look like the original triangle that those children have seen, but it's not a closed triangle. So that could be such things as, vertices perhaps not linking up. That could be perhaps something like taking a part out of one of the sides of a triangle, so that they can see that therefore, that triangle doesn't become closed. It no longer has three sides, for example. Then there's fusion, and fusion is sort of it's a process where the learner sort of discerns several aspects of a phenomenon that vary simultaneously. So let's say, for example, I just have an equilateral triangle of a various size. What I might do is I might rotate that 90 degrees and increase the size of that triangle or decrease the size of that triangle, so that then pupils can see how okay, there are two of these things that we are changing, its rotation and its size. However, that still infers that we can still infer that this is still a triangle. And I think for teachers who have experienced teaching children, particularly with shape, with regards to having just a square and rotating it around 45 degrees, so it looks like I'm going to be killed by the maths the listeners here. So it looks like a diamond. Please note the inverted commas there. Children will naturally say, "Oh, that's a diamond," because that's what they associate with that. They haven't seen a square that has been rotated just those 90 degrees and maybe made a little bit smaller or larger, whatever it may be, to associate the fact that this is still a square. And then finally, within the Martonian theory of thought, you have sort of generalization, and that's like a combination of contrast, separation, and fusion, where you kind of discern these aspects sort of in the real world, as it were. So the idea then that a triangle can only or understanding the meaning of triangle can only be achieved after the learner has experienced various triangles that have been constructed from examples and in the real world. So you may point out triangles throughout architecture, for example, or whatever else it may be. Looking at the pyramids, for example, and looking at the one of the sides of them and being like, oh, that is a pyramid, for example. So that's the sort of Martonian way. So we have this kind of idea of contrast. So this example, non-example. We have sort of separation where we are just varying sort of one particular aspect, keeping everything else the same. Fusion, where we're changing multiple aspects, and then hopefully generalization. Where we find variation in capital D, capital I direct instruction, we find that in what we call the setup principle. And again, here they do use, I think it's important to say just the language that I used previously, example, non-example, is not something that I've seen explicitly used in sort of Martonian literature. I don't know if you have come across that, Kieran, or not, but certainly nothing that I've seen where they use those particular terms. However, we do see that a little bit more in, as I say, capital D, capital I. So I say we have the setup principle, where we want to vary only one particular thing. I'll use my best descriptive language to kind of explain the concept here. So imagine that you have a box that is, or a square that rests on a vertical line, and that square is gray. And then next to that, you have another square that hovers just above this vertical line, and that square is exactly the same as the other square that sits on the vertical line, and same shape, same size, everything about it is the same. The only thing that differs is that one is resting on the line, one is sort of floating just a little bit above the line. That is the idea. So the idea there is that you are keeping as many of these different things the same so that children understand the concept of the preposition on. They contrast that with another example where the square is still resting on the line, but they have a darker grayed circle that is floating above the line, and that is, typifies something that doesn't follow this setup principle, because what is on isn't clear. Is on the fact that it's a circle now, is on now the fact that it's a different shade of color. And if you're not that clear in your communication, that might be something that pupils take away. So the setup principle, you only want to vary one thing, and that one thing is that understanding of the concept that you want pupils to learn. Then they have what they call the difference principle, and this kind of is used to illustrate the limits or sort of boundaries of a concept. And you want to really make sure that you take your pupils through sort of that whole kind of continuum of what that idea is, from the clear example of what it is to the clear example of what it isn't, and everything in between. So if you wanted to teach about what a horizontal line is, for example, you would show them what a horizontal line looks like, but then you wouldn't just show them a vertical line and say, here's horizontal, here's vertical. You'd want to show them that line sort of going throughout that 90-degree rotation, and all the pointing out when, you know, this is a horizontal line, this isn't, it isn't when it's at 10 degrees, it's not when it's at 15 degrees, etc., etc., etc. So really kind of showing the broadest range of what this concept is and isn't. Really kind of similar to that, then you have the difference principle, but then you also have the sameness principle. So this is sort of an understanding that, again, animals is a really good one for this. So it's no good that you kind of just show similar examples of what a dog might be like, for example. So you're not just going to pick, small dogs to exemplify what a dog is. You really want to go for, the whole broad spectrum to really emphasize what is the same about these things. So you would want to show, for example, a Chihuahua and juxtapose that with an Irish Wolfhound, perhaps. I think those are the biggest that I can think about with in terms of its juxtaposition in size and shape and whatnot, so that children can understand, okay, so here are things, they look really quite different, but they are effectively still part of the same, familiar. So that's the sameness principle. And those are the three main areas where we see variation within direct instruction. Bianchi, if you belong to a maths hub, I believe they use this sort of distinction for variation theory, this idea of procedural variation along with conceptual variation. So procedural variation is where we introduce a little bit of variation to the problem. We might expect pupils to find sort of different solutions to the same problem, or one solution may be applied to plenty of different problems. So, for example, you may say that there are 9 liters of apple juice, and every 3 liters is going to be put into a jar. How many jars are needed? And then you might vary aspects of that to show a concept. So instead of putting 3 liters in a jar, you might put 1 liter in a jar. You might then say, oh, I'm going to put 0.3 liters in a jar. And so at that point, we're kind of understanding, oh, okay, when we're dividing a number, actually, our number doesn't have to get smaller, for example. And then we have ideas, say, around sort of conceptual variation. And this is definitely where this idea of standard, non-standard, and non-examples comes through. So again, thinking there of the sameness and the difference principle from capital D, capital I direct instruction. That's very much this idea of kind of contrast and separation as well within Martonian ideas of variation. And then sort of, finally, we have the variability effect, which is an effect that comes from the cognitive load literature. And so here we kind of talk about structural features and sort of surface features, and how if we include, let me make sure I get this right. So high variability tasks have a higher element interactivity, i.e. there are more working parts that we need to sift through to understand, compared to low variability tasks, because we need to process more elements simultaneously in working memory to understand the task at hand. As we sort of increase the variability, the number of interacting elements increases, because learners, they have to distinguish the variety of tasks that require a similar solution. So an idea here of low variability might be something like we are working within numbers within 20. We're getting pupils to do some basic addition, and effectively all the additions that you do relate to number bonds to 10. So it may be fine for certain people, but certain people may find that not particularly challenging enough. High variability would sort of look like where perhaps you provide an example for them, but you're not just picking bonds to 10, you are then picking perhaps bonds to 20. You are perhaps actually not just providing 2 numbers, you are providing 3 numbers which they need to add, or 4 numbers which they need to add, or 5 numbers that they need to add together. Depending on where these pupils are in their journey, you might throw in a negative number with which they need to add a positive number to. That's they're kind of creating high variability, because you're kind of gradually increasing that particular challenge of that activity. even though what we're doing is asking pupils to add, numbers within 20 still, or only using numbers 0 through to 20 for which to create additions. So we won't perhaps, So again, that aspect, the variability effect, very much sort of leads into this kind of more procedural variation that we see within Bianchi as well. So yeah, that's kind of where we see variation in all of those 4 different areas.
I know you felt like you were talking for a long time, but I think that was probably the most important bit. And probably the reason for this episode is to encourage listeners to join us in this rabbit hole, to go and look at the variability effect and to look at the research into variation and see, what that might mean for their practice. Because I do think, well, how can this inform us in the classroom? There's at a certain point we need to discuss what implications this has, because I think there's a lot of discourse about whether or not the reduction of variation theory to a discussion about examples is helpful or not. But I think one of the most supportive ways for teachers is to think about, it is you're essentially focusing your attention on the ways in which you ask questions, the way you structure your tasks, and the things you try to make possible to discern for your pupils. And I think at some point, that does come down to examples. And so the point of this episode was to suggest that here's something that might be of interest. Because at the end of the day, we're 2 teachers who find something interesting or read lots of interesting papers, think we've found something worth exploring, and we'll continue to explore over the next how many years. And I think once we've done our round of talks, when we say we're going to Warrington in 2nd of March, I think we've got Birmingham on the 16th of March, and then maybe the Southwest, Gloucester on 27th of April, I want to say.
Yeah.
So I think after that, really then thinking about how do each of these phenomena and the crossovers in phenomena impact our decision making in the classroom. And so what we could do is we could sit down and give the audience one of those 2-hour specials that we we used to crank out all the time. But I think what we've done is we give people a reason to think about variation theory. Like I said, it is a contested space, but it's also a very interesting space. And what we want to do is we want to be the bridge between factions, because really, I'll give a historical example. These different fields, they aren't the Anglo-Saxons and the Normans. They're actually the brothers of or the sons of William the Conqueror, and they have their differences, but they've got more in common than they realize.
Certainly.
That's what I think, anyway. But it's been an absolute pleasure. I'm looking forward to seeing that. I hope, and maybe we do the talk for YouTube as well, if for those who can't make it to Research Ed before September, because it's not always easy. All I have to do is say thank you very much for joining me. Thank you very much, Neil.
Thank you very much for having me.
To everyone at home, until next time, thanks for listening.